In this video, we're going to review how kinetic energy is related to dynamic pressure, specifically through the work energy theorem. So to start, we know that work is equal to some change in kinetic energy. If there's no changes in kinetic energy, work is just equal to the kinetic energy. And we also know that kinetic energy is equal to 1/2 the mass times the velocity squared. Instead of saying that work is equal to kinetic energy or kinetic energy is equal to 1/2 mv squared, we could also say that work is equal to 1/2 mv squared. Now, if we divide both of these by the volume in which the work is being done, then work over volume, we know that pressure is equal to work over volume. So then we could, instead of saying work over volume, we could then say pressure equals 1/2 mv squared over the velocity. And because we had the 1/2, this 2 is in the denominator and goes with the volume, not velocity. 2 times the volume. Little v velocity, big V volume. So now we've got pressure. Now the other thing that we know is that density, which in math terms is referred to as rho, which kind of looks like a P, but like a cursive P-ish. So we know rho is equal to the mass over volume. If you don't understand how density is equal to mass over volume, check the description below for a video describing density. But here, just remembering rho, or density, is equal to mass over the volume. You see here, we've got mass over volume. So now, instead of having pressure is equal to blah, 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 we can say the pressure is equal to, and then this 2 is still going to be in the bottom. We're going to have the 1v squared, and now this is going to be, instead of mass over volume, we're going to put a rho here. So the pressure, in this case, the pressure that's coming from kinetic energy, and because it's coming from kinetic energy, it's described as dynamic pressure. So the dynamic pressure is going to be equal to 1/2 the rho, or the density of whatever volume, whatever fluid or gas. In the majority of the time we're talking about fluids. Whatever fluid you're talking about, it's density, times that fluid's velocity squared. So the dynamic pressure is 1/2 rho times v squared.